What's up, everybody? It's me! Ha! What's better than one math teacher? Two! Ha! What is up? We, both of us, are glad that you are here for another math lesson. We are talking today about translations and reflections. High five. I just high-fived myself. That is sick. So we're shifting gears a little bit. We are going into geometry. Okay. I want myself back. Where are we? There we are. So little admission here. This might be the worst lesson I ever taught in my career over the last couple of years. So I apologize to those students. I have spent a lot of time fixing my lessons and my assignments to be better for you this year. Okay, so listen up and stick with me. Okay, if you are watching this live in the chat, let's have some fun. Let's do this. If you are watching post, like you're watching after it is live, if you feel comfortable with Cartesian planes, if you feel comfortable with Cartesian planes, that's fine. Then you can skip ahead until you see this slide. Okay? Actually, backtrack a little bit to this slide, word wall. Okay? Find that slide and jump ahead to that. I'm going to quickly kind of just refresh. But for now, what I want everybody to do is get your title down and your table of contents updated because we need to be taking, trust me, you need to take notes. If you have grid paper, this is a lesson to use grid paper for, okay? You need grid paper for this lesson. Hey, look, it's only one of me. That sucks. I know you like two of me, okay? So if you have grid paper, use your grid paper, okay? So we are in GS, we are in geometry and spatial sense, okay? I did it in a weird order, partially because of COVID, and this will kind of lead us into maybe our linear patterns and kind of help with the terminology and lingo. Okay, you are going to need to be able to, according to the curriculum, represent transformations. We'll talk about that word using the Cartesian coordinate plane and make connections between transformations and the real world. Specifically in grade 8. You need to be able to identify and draw translations and reflections. Okay? This is a graph. You've been using these graphs for a long time. Okay, I am going to fly through this part. This is not the lesson. This is me covering what you've been doing for a couple of years. Okay? So I apologize. If this is too fast, you're going to have to go back and just pause the video and slow it. Lucky for you, I lost my mouse. There we go. Okay, this is a graph. This is a Cartesian plane. Okay, this is important for high school. You really need to understand this Cartesian plane concept. Okay, you need to know the terms. That's why I'm going to go over it. Okay, there are 4 quadrants. This is quadrant 1. Okay, this is quadrant 2. This is a common mistake. A lot of times people think that we're going in this direction, and it's just because they forget. Okay, they think that this is 2. This is not 2. Okay, and that does matter because especially in high school they're going to say something located in quadrant 2 or quadrant 3. Okay, so you need to know this, that this is 1, 2, 3, 4. Okay, super fast game just for those in the chat. Ready? What quadrant is this? What quadrant? What quadrant? What quadrant? What quadrant? What quadrant? What quadrant? Which quadrant? Which quadrant? Which quadrant? Which one? Whoa! That's not in a quadrant. That is on an axis. Which axis? Tell me in the chat. Yes, it's the y-axis. That is the y-axis. That is not in a quadrant. That is between quadrant 1 and 2. That is not in a quadrant. Okay? That's in a quadrant. That is not in a quadrant. Okay? That is not in a quadrant. That is still the y-axis. It's in the negative half. Okay? But it's in the y-axis. This is the x-axis. Excellent job. Excellent. Okay, this is in the first, second, third, fourth. Okay, we feel good about that? If you're good in the chat, say, got it, MrStav, got it, got it, got it. If you're not good, at the end of this, go back and take some tight notes, okay? You need to understand that this horizontal axis is called the x-axis, okay? We're not referring it to the sideways one and the up and down one. We're not calling it that, okay? And in grade 9, they're not calling it the sideways one. They're calling it the x-axis and the y-axis. You need to know that, okay? So that's our x-axis, and this is our y-axis. Okay, I hear my perfectionists in their note taking say, MrStav, slow down. Okay, boom, take a screenshot. Right, you can't do it in the classroom, but you can do that here. Take a screenshot of me. I'll smile for you. There, good, good. You got it. Okay. Now, when we write out coordinates, okay, you know this, but you forget probably. We have a little strategy in remembering that the x-axis always comes before the y-axis because in the alphabet, Q, R, S, T, U, V, W, X, Y, and Z. Okay, X comes before Y. And so when we report coordinates, okay, or ordered pairs, we're always going to report the x-axis before the y-axis. Whenever we do any movement, we're going to move in the x direction, or in the x-axis, and then we're going to move in the y-axis. Okay? That's going to be important. Okay? Maybe you're like, MrStav, I know this. Maybe just write down this strategy because I thought it was a good strategy I came up with, and I kind of like it. Okay? Huh. I know Tiana's not writing it down right now, but that's okay. All right? The x comes first. Remember that. Okay? Again, I'm flying through, guys. Okay? All right? In the x-axis, we have positives and we have negatives. Okay? As you go to the left, there we go. You got to figure out the camera coordination. As you go to the left, you're going more in the negative direction, and as you go to the right, you're going more into the positive direction. So you're getting higher, and you're getting lower. Okay. So anything in quadrant 1 or 4 will be positive, and anything in quadrant 2 or 3 will be negative. MrStav, slow down. I can't. I have so much more of the lesson to get to. This is not the lesson. This is just review. Okay. In the y-axis, okay, as you go up, we get positive, we get higher, and as you go down, we get lower. Okay, so anything in quadrant 1 and 2 in the y-axis will be positive, and 3 and 4 will be negative. Okay. Let me ask you a question. Let me know in the chat. Is there a quadrant that both the x and the y are negative? Okay, and somebody said this in the chat last lesson. Somebody already said that. Like, I don't care. I don't care if someone's already answered a question. You pop in. If you got it, pop it in. I love as I'm sitting there chatting and typing. I love seeing that people are engaged. Okay, so if you see someone answer it, still go ahead and answer. Okay. So is there a quadrant that both the x and the y are negative? Seeing it in the chat, loving it. Yes, it is. The only one that is a double red is quadrant 3. Okay, the most red one is this one. Okay, and then in the x-axis, this is the negative, and in the y-axis, these are negatives. Okay, and the opposite question would be: is there a quadrant that both x and y are positive? And your answer is quadrant 1. Okay, they're both positive. Okay, no flying. Okay, plotting a point on a Cartesian plane. Okay, just like when you were on a graph, we always start at 0. Okay, on a Cartesian plane, the 0 is called the origin. Okay, it is our starting point. You always start at 0, 0. Okay, I need to move my head over here. Okay, and then what comes first in the alphabet, the X or the Y? Okay, so we always move in the x-axis first. So we're going to move the number that the x is. So in our case, it was 6. Okay, now you notice that the dot stopped at 4, and that's because this is a common error where people will move the value of the y-axis in the x-axis. Okay, it's just a oopsies mistake. It's not, oh, I'm dumb or bad at math. It's just like sometimes you have a little brain fart. Okay, so make sure you're using you're going all the way to 6. Okay, that x-axis that you're reading the x coordinate. Okay, now also make sure you're going in the right direction. Okay, because this 6 is positive, we're going up. We're going to talk about that later in the lesson, don't worry. Okay, and then from there, we're going to move in the number of the y. So we're moving up 4, right, and you plot your point. Okay, all the steps are the same in a Cartesian plane. The difference being here is that we have negative values in a Cartesian plane. Okay, so again, you start at 0 at the origin, okay, and you move the number of the x. So here we're moving 6 again, but we're going to go in the negative direction. So make sure you go in the right direction, or the correct direction, I should say. Less confusing. Okay, so I'm going in the negative direction. Okay, I'm moving 6. Okay, and then from there, we're going to go up or down. Tell me in the chat. Are we going up or are we going down? Tell me in the chat. Chat, yell at me. I want to see it blow up. Everybody should be saying down. That's right. Nice. Lots of downs. Good. Okay, we're going down 4. Okay, and you plot your point. Okay, when we say plot your point, it means name it or put its coordinates next to it. Okay? Same deal for reading a point on a Cartesian plane. We always record the x value first. Okay, so there that line goes. We are over to the right 5. Because it's to the right, we are going in the positive direction. So this is positive 5. And then we're going down in the y-axis to a value of 3. So we're going down 3, which is negative 3. Okay, here's another example. Going in our x-axis first in the negative direction. So that's a negative 7. And then we're going up in the y. So we're going up 7. Okay, that is how we read a Cartesian plane. Okay, here's where the lesson starts. Okay, so I'm going to wave my hands. I'm going to go to this, be like, ah! To try and draw the attention of those people that were skimming and cheating and not watching that first half of the lesson, or first little intro of the lesson. Okay, this is where I'm going to introduce some very important words that I would be writing on our word wall in the classroom, but we don't have our classroom. Here. So, write this down. A transformation. Okay, a translation and a reflection. What we're learning today is us transforming a point or a shape, okay, or a figure. Okay, so we are changing the position. Okay, so my phone is here. If we transform it, we can move it over here. We can transform it over here. Okay, this is a transformation. Okay, you're kind of familiar with that word, not a shock to you. Here's a new word to you. Okay, pre-image. Okay, we are going to be using this word pre-image. Okay, as if you've been using it for years. Okay, so when we refer to this is my phone, and then I move my phone over here. Okay, that's a transformation. So before we moved it or transformed it, that's its original figure. So that's what we call the pre-image. And don't worry, we'll give you lots of examples, and I'll be using that word a lot in this lesson. This is the pre-image. Then it transforms. What do you think? Tell me in the chat what you think this image is after the transformation. Okay, tell me in the chat. Okay, I love when you guys chat. Okay, so here's before the transformation, we call it the pre-image, and then this is called the image. I know a lot of you are guessing post-image. It is not, all right? It's called the image. Okay, this is the figure now after a transformation. Okay? Write that down. Cool? All right. This prime is often forgotten, okay, and often it'll cause loss of marks. This is kind of like your units, okay? It's like putting centimeters or centimeters squared. Like often students will forget this, and I don't blame them, okay? But what I'm going to suggest to you is get used to this. Use this in your speech, in your vocabulary, as much as you can. So the word is prime, not prime numbers, okay? What we're referring to is this mark. This. It's like an apostrophe. Just going to circle it a lot while you write things down. Okay, we're going to use this to label not the pre-image, okay, which is the starting figure, but we're going to label the image, okay, which means after the transformation. So we're going to use this to show that a change has occurred. Okay, so this would be phone. Okay, and then we're going to translate it over here. And this would be phone prime. Phone before the change, phone prime after the change. Okay, you're gonna see that a lot this this week. Okay, as you do your stuff. So let me use these words in action. Let me show you them on a Cartesian plane. Okay, let's move me over here. So here we have point A. Okay, and remember, before we moved an object, because we are going to transform point A and make it to A prime. So we're calling this the pre-image. This is point A, it's pre-image. Okay, and then we are going to look at that. What an animation. That is PowerPoint level 2 for all of you following at home. Okay, so we are translating, or we're transforming this point. Okay, so the green one is the pre-image, and now the purple one, you guessed it, is called the image. Now, think back to that last slide. If we had called it phone, phone prime, what do you think point A is going to be called after its transformation? The image, what do you think it's going to be labeled as? A prime. Okay, so important that you get this. Okay? Really want you to know that this dash is not there by accident. It is not an oopsies. It's not an exponent. Okay? This is prime. Optimus Prime. No, this is just prime. No, not Optimus Prime. All right? Okay, so you need that A with the apostrophe. Okay? And if you're wondering where the apostrophe is, it's right there. Okay? Okay, it's right next to your enter key. That's the one, if you hold shift and press it, you get the quotation marks. Okay. Now, I'm actually going to transform again. Okay. I'm going to take A prime and I'm going to transform him again, or her. Okay. So I'm shifting its location another time. So what might we call this? If this is the pre-image and this is the image, what do you think we call this? Put your guesses in the chat. And these are straight up guesses. I have no judgment of you. Okay? I love that you're guessing. Bonus marks for getting it wrong. Okay? I guess I can't give marks for participation. You know what I mean. Go ahead, give it a shot. Okay? I don't think many of you guessed this. Okay. First of all, we're calling this a double prime. Okay. However, that animation was out of order. I wanted that later. This is still the image. Okay. This is the image of A prime. So now A prime becomes its pre-image. And this is really just blowing my mind and like, oh, what's going on? Okay. But the original image was this one, and then we moved it to here. So the pre-image, then this became the image. And now since we're moving this, we're gonna make this our pre-image and make this our image. Not confusing at all. So since now that's just like a little bit of overload, I think it's simpler if we just stick with A prime, and A double prime, or 2 apostrophes. Ready for me to blow your mind? What is this? If this is A prime, and this is A double prime, what are we calling this? 1, 2, 3. 1, 2, 3, 4, go. Okay, we'll just keep going. Every time we move it, we'll add a prime. Okay? Now, MrStav, why don't you just label it a different letter? So why don't you make it A, B, C, and D? The reason why is because we need to remember or make record of the fact that we have moved this A triple prime, that its original location was all the way over here. So that it went on this journey, and became there. Okay? So by keeping it, this is still A. Okay, so it's like if I took, let's say Kenna. Let's say we take Kenna and we move her to a new location. This is her Kenna Prime. This is her new location. Okay, but she's not a new person. I couldn't just name her Tiana now. Okay, she's still Kenna. She's just in a new position. She's in a new place. Okay, so we're just going to indicate that this is Kenna later in a new spot. Okay, and if she starts talking again and I have to move her to a new seat, I say, Kenna, be quiet. And I move her to a new seat. This is Kenna double prime. Okay, that makes sense? I picked Kenna because she talks a lot. Okay. All right. So here's the word from the curriculum, translate, translation. Okay. So, oopsie, I'm on the wrong screen. Got to move me out of the way. Here we go. A transformation, or a translation, is a transformation where all the points of a figure are moved the same distance in the same direction. Okay? Why does this matter? Okay? I want you to notice the shape here. Okay? You notice the shape? You notice how it didn't change. It didn't grow. It didn't get bigger. It didn't shrink. It didn't get like wonky. Okay? So it's not like that. Okay? It didn't change in size. It didn't grow. It didn't turn. Okay? It literally just shifted. Okay? It's somewhere else. Okay? So going back to Kenna. Kenna talks. Okay? I'm just moving her seat. I'm just moving her somewhere else away from Deanna. Okay? So that but she stays the same. Okay? So there's all the points of a figure are moved the same distance. So point meaning here. So this point is moved like this, and this point is moved like this. I'm actually wrong there because I should always be going in the x-axis first. Thank you to Justin for correcting me there. Whoop. Okay. So I was just mostly messing around to buy you guys time to copy that down. Okay. So going back to our example here, we have A and A prime. You remember this? Okay, so A is translating 4 units to the right. Okay, I don't know if how easy this is or how hard this is without grid paper, but do your best to take these notes. Trust me, it'll help you. Okay, 4 units to the right. A prime or A is moving 4 units to the right, and then it's moving down 7 units. What are you talking about units, MrStav? Well, 1, 2, 3, 4, and then 1, 2, 3, 4, 5, 6, 7. Okay? So our therefore summary statement, move me, we could say, therefore, image A prime, okay, so the new image of A, okay, is translated 4 units right and 7 units down from pre-image A. Woo, that's a lot. That's a lot to say. Image A prime is translated, so it's moved 4 units right and 7 units down from its original pre-image A. Okay. Just gonna flip over while you write that and check my time here. I'm gonna pick it up because I don't want this lesson to go too long. Okay, so you can come back and write this down, or maybe take your phone, just take a quick picture and copy the rest down after. Okay, so you're going to get a question like this. What are the coordinates of the translated points? Okay, so I'm giving you this as the original point. Here is L, okay, and the coordinates of point L is -1 and 6, okay? And the translation that you are doing, we're going to move this 5 units to the right and 4 units down. Now, there's just doubt. Do I have to pull out a Cartesian plane and graph this and then go 1, 2, 3, 4, 5, 1, 2, 3? Okay, you do not have to. Okay, I'm going to show you mathematically how we can do this, how we can approach this. Okay, so we're going to come up with our new coordinates. Okay, and what is the name of the new coordinates or the new point? What's the new point? Okay, if the original point is point L, what's the new point? Tell me in the chat. L prime. Optimus Prime. Okay, L prime. Okay, so now we have to translate and move these numbers. Okay, so a lot of animations here. It took me forever, but this is hopefully going to help you. So we are moving in the X direction to the right. Okay, so when we move in the X direction, moving to the right brings us to more positive, and moving to the left makes us more negative. Okay, just think about a number line or counting, right? You're moving, you're taking away to go to the left, and then you're adding to go to the right. You're getting higher, you're getting bigger as you go to the right. Okay, let me write 1, 2, 3. Okay, so we're going to be saying, since we're going to the right, we're going in the positive direction. Okay, so what we're going to do is add. That kind of looks like a multiplication sign, but that's a plus. I tried to write it on an angle, and I didn't really consider it. Okay, and how much are we moving it to the right? We're moving it 5 units to the right. Okay, so let me bring it down here and summarize this. So we're taking -1, and we're adding 5, or we're going to the right 5. We're adding 5. So -1 plus 5 equals 4. Okay, do you see where we got that from? Do you see how I got that? Okay, important that you understand that. Okay, if not, look at the timeline and maybe write in your notes at 26 minutes and then circle it, and you can come back to it and rewatch it with my animations, okay? Now the second number in the y-axis, now y-axis is the up and down, the vertical, okay? So we're moving 4 units down, okay? And when we look at our Cartesian plane, when we're going vertically up and down, like a number line, as you count up, you're increasing, or you're going in the positive direction. Or as you go down, you're moving in the negative direction, you're decreasing, okay? So since they're going down, we're decreasing, we're coming down, we're taking away, so we're subtracting 4. Okay, so come over here. So it's starting at 6, and then we're going down 4. Like envisioning STAV towers in our classroom, right? So 6 take away 4 leaves us with 2. So the coordinates of L prime are positive 4 and positive 2. Okay? So the pre-image is L, and its coordinates are negative 1 and positive 6. And its image, okay, after we've translated, after we've moved it, L prime is positive 4 and positive 2. Okay, so if I was to quickly look, it'd be like negative 1 and positive 6, kind of be there, L. And then it gets moved to 4 and to about there would be L prime. Okay? Okay, let's try R here. Okay, we're going to the new point. So how do we label that? Tell me in the chat. R prime. Okay, we're going to the left this time. So we kind of look over here, and going in the left direction is our going in the negative direction. So we're going to subtract how many units to the left? We're going to subtract 2. Okay, so 0 take away 2 brings us to negative 2. Okay, and then the y direction, the y-axis, we're going to go 5 units up. Okay, coming over here, going in the up vertical direction, brings us into the positives. So we're going to add the number of units that we're going up by, which is 5. So we put it here. So 8 plus 5 equals 13. So our pre-image was at 0 and positive 8. And our R prime, our image, is at negative 2 and positive 13. Whoopsies! Go off the map here. Okay? That is after its translation. So I want to move on, but maybe make a note to yourself that you can come back and try this last one. Or maybe do it. Do it now. Let me give you 30 seconds to do this one. Okay? Feel free to share it in chat when you get your answer. And I don't care if other people have posted the answer. I want to encourage you to also post your response. Okay? I love it. And I'll say your name, and I'll say FTW for the win. For the win. Bring it on. Okay? So move this pre-image of Y. Move it 4 units to the left and 3 units down. Okay? And again, I am moving a little bit quicker because time here. Trying to squeeze all this into one lesson and not bore you to death. You're not bored, are you? In case you're bored, I could always go back to 2 of me. Or maybe Kiana would prefer none of me. Okay, back to it. All right, so the answer is y prime. And yes, if you don't write, Mr. Stav, what if we don't write it? You will lose half a mark. Okay, so y prime is positive 7 and negative. It is not positive 7, negative 3. Whoopsie doopsie. Gotta fix that in my slides. All right, so it's going to be 4 units to the left. Oh, man, so 7 take away 4. Okay, 3. Good. And then negative 3. 3 units down, so we're down is in the negative direction. So I'm going to be going away from 0, so I'm going to go negative 4, negative 5, negative 6. Awesome. For all you in the chat for the win, nice job. I messed it up, but you were there. Okay. All right, here's an important word. This would be huge. This would be all over your math journal. Okay, this word, vector, write it in. Moses, write it huge. Marcus, write it in huge. Okay. I apologize to Moses' family for the paper that he will waste writing vector. Very big. All right. So vector is a quantity that has both length and direction. Here's what I'm most worried about. This is the big part of the definition here. The vector, pointy bracket, x, y, that did a really bad job, and closing pointing bracket, lists the horizontal and vertical change. Change is the key word. We've been talking about change, translations, transformations, okay, changing. So a vector lists the change from the initial point, from the pre-image to the image, to the final point. And what's important here, notice the angled brackets. You'll notice I butchered it, okay? Look at these. Shing, shing. The angled brackets, not a mistake, definitely on purpose, and you definitely need to know this, okay? In fact, I'm even going to pull up, grab into your camera, grab your Chromebook, and throw it on the screen. There it is, okay? This is where you find those angled brackets. You've probably seen them your whole life and been like, why are these even here? No one ever uses these, okay? We are going to use them for a little bit here, okay? So a vector, we can write like an ordered pair using these vectored brackets. Okay, so instead of the curve, it is not the curved parentheses that we've been using in BEDMAS. Okay, they're the pointy. They're very different. Okay, so going back to the last slide, we said translate this point, and then we gave a whole bunch of text. Let me fly back. Okay, see all the text that we had to write here? Okay, we can actually say that same thing a lot more succinct, a lot quicker by using vectors. Okay, so what we're going to do is just read this. So check this out. We have the vectors, the pointy brackets. Let's clear out all my ink. Okay, and that negative tells us which direction we're going, left or right. Tell me in the chat. Does negative mean left or right? Okay, we're going in the negative direction. We're taking away. Okay, and we're taking away 2. Yes, we're going left 2. So the x is going negative 2, and the y is going positive 4. So I can come down here, see where we have u, which is 7, and I can do the math. So I can take away 2 from 7, and I can add 4 to 2. Where did I get those from? From here. I'm moving to the left 2, so the left 2. Take away 2. And moving to the right, which is a positive. We don't have to write positives if it's positive. So but here we're adding 4. So 7 take away 2 is 5, and 2 plus 4 is 6. Okay. I am going to slow right here for a bit because I know that some of you are perfectionists and like to write the entire slide down, even though you don't need to write the whole slide down. But I will let you kind of catch up a little bit. Okay. Again, though, I would maybe recommend writing down what time it is on the video. Let's say it's like 30 minutes in. Okay, and then take a picture and then come back to that later after the lesson. Okay. So I want to jump back all the way to our first example. Okay, remember we had A and A prime, and we moved it 4 units to the right, and 7 units down. Move me out of the way again. Okay, and then we had this super long therefore sentence. Image A is translated 4 units right and 7 units down from pre-image A, and I didn't give you enough time to write that down. It takes forever to write these sentences out, but it doesn't take forever to write a vector. Okay, so since it's 4 units to the right, right is positive. Okay, so we don't have to write a positive 4. We're just going to write 4, and 7 is in the down direction, which is a negative. So we're going to make that -7. So we have vector 4, positive 4, -7, closed vector. Okay. Hopefully you see how vectors are going to make our lives easier. I know I'm going to get to guided and I'm going to have people say to me, MrStav, why is that bracket pointy? Okay. I really hope that you take this in. The pointy brackets are on purpose. They're for a reason. And it's all about the movement. Okay? These are the instructions. These are IKEA instructions. Instead of writing it out, IKEA draws it for you. So we're drawing it for you. I literally thought that on the moment in the spot. Never said that before. I like that. IKEA. Okay. So you're going to see questions like this. And again, I would recommend that you come back to this and try this. Okay. But you're going to see translate the figure. Okay. So let's say that I give you a triangle and it's point U, T, A. Okay, and you connect it because it's a figure. So you connect the dots, you have a triangle, it's UTA, and then I give you this vector and I say move the entire figure. Not just point A, but move point U, point T, and point A. Move all 3 of them, move them 4 to the right and up 4. The reason why I know the direction is because this is a positive and this is a positive. Whereas down here, I would say move it in the negative direction. So move all these points left 2 and move them up 4. So for each of these, you're going to take away 2 from all of the x's. Okay. And then you're going to add 4 to all of the y values. It's not easy with a trackpad. Okay? So maybe take 20 seconds and do the first one and then come back to this at the end. Okay. I do need to move on. So take note of the timeline and come back to it. Okay. So here are the answers. So when you come back after the lesson to do these, to practice, okay, I want you to be able to see the answers and be like, oh, I nailed it. Okay. Please note, prime, 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 prime. So this is T prime, A prime. Okay. That is part of the mark. That is part of my expectation. Okay. You notice that we don't have to move these. This is not a point to be moved. That's why it's a different shaped bracket. This is the vector. Okay. Woo! One of my favorite parts of the lesson. I might get flagged on YouTube for this.
Look at me, I will never pass for a perfect bride or a perfect daughter. Can it be? I'm not meant to play this part. Now I see that if I were truly to be myself, I would break my family's heart. Who is that girl I see staring straight back at me? Why is my reflection someone I don't know? Somehow I cannot hide.
Sing it, girl.
Who I am. Though I've tried, when will my reflection show who I am inside? When will my reflection show who I am inside?
That's beautiful, Milan. That is beautiful. That is beautiful. Milan. Couldn't have said it any better. We are now going to talk about reflections. Okay, hello, emotionals. And I know you're emotional. It was beautiful. It's a great movie, by the way. I think they're doing a remake. So, it's a good movie. We're talking about reflections or reflecting now. So before we translated, okay, up, down, left, right, okay, now we are going to reflect. Reflection time. I know. Go back. So you're going to get a question, and it's going to say reflect point S, or reflect point B, or figure ABC. Okay, so in our example here, it's going to say reflect point S. Okay, and then it's going to give you the mirror. So I actually there's a purpose for this. Okay, so let's take my phone, the reflection point. So everything from the reflection point, okay, to the point. So if this is point S, okay, you'll notice that on the left side and the right side, the distance is the exact same from the point to the mirror, from the point to the mirror, from the point to the mirror. Okay, so when we go back to our Cartesian plane, the question here, let's keep it simple, and it's going to say reflect over the y-axis. So this question is saying that this y-axis is our mirror point. Mirror point. It's our reflecting point. Okay, so the same distance, equal distance on both sides of the mirror. Okay, and I'm not going to all of a sudden drop this down here because that's not how mirrors work. Okay, the S point doesn't come down here. Go back to your mirror, right? The height of my nose is the same height on both sides of the mirror, okay? And it's the exact same distance from the mirror point, from the reflection, okay, on both sides of the mirror. So when we come here, S, this is the pre-image, so the image after the transformation is going to happen, after the reflection, okay, S prime is the exact same height, okay, or y value, and its x value, the distance has changed. So now we would say that S prime is +5, +8. Okay, over here, its original image is -5, +8. Okay, the big difference here is that negative factor, that negative sign. Okay, so notice the 8 is the same, and the 5 is just turned from -5 to +5. Okay, that's all reflecting is. You find your mirror point, you count. How many units? 1, 2, 3, 4, 5. 5 units to the mirror point. So then from the mirror point, 1, 2, 3, 4, 5. 5 units to the mirror, and then 5 units away from the mirror. That's your image, okay? Your S prime. Does that make sense? Okay? This is nonsense. Don't look at that. Cover it up. There we go. Aha! God. Okay. Now this works with shapes as well, or figures, as they say. So it's going to tell you reflect triangle Jer, J-E-R. J-E-R. Shout out to Jeremy. Yes. Hopefully he's watching live. Jeremy, if you're watching live, let me know in the chat so I can give you a shout out. Jeremy for the win. Okay. So what you have to do here is you have to reflect every point. So point J has to be reflected. Point E has to be reflected. Point R has to be reflected. Okay. So let's say the question is going to stay the same in telling us to reflect over the y-axis. Okay. So let's start with point R. The distance, that's a pretty far distance. So we have to go the exact same distance. So I'm going to count it. 1, 2, 3, 4, 5, 6. Now, some people in the chat are yelling at me. I can hear it. I can feel it in your bones, your veins. You're just like, there's a STAV. I can definitely tell Lumina is feeling this way. Okay. The R. Just look over here. Oh, if that's -15, that's -14. That's easy, MrStav. So I don't have to count all the way there. I just know that's, oopsie. Yeah, it's -14 away. Okay, so I just have to go to my -14, come to the same height, and plot my point. There it is, R prime. I think I nailed that. Okay. Now these are a little bit easier because they're closer. But yeah, this J is just before the -5. So we know that's -4. So we can come here to +4 and shove it like it's hot. There's J prime. Okay. And then E prime, the same distance away from the reflection point, E prime. Okay. Once you've reflected all the points, you can go ahead and connect the dots. Okay. Wait a minute. The triangle's different. It looks different. You'll notice it's not been slid over. That's a translation, right? Moving a triangle and then sliding it over is a translation. But this one has actually been flipped. It's actually, oopsie doopsies, don't do that. It's actually been reflected. Okay, so the triangle is here, and it's reflected. Can I make a triangle? Triangle. Okay, there it is. Okay, they're reflected across that mirrored point. Okay, and you can add in your, move me out of the way. Add in all of your Cartesian planes. Now I've made a oopsies. Check this out. I forgot to add J prime here and R prime here. I apologize. That's Marissa's fault. Sorry about that. It's her fault. All right. I was going to blame Cole, but he probably would appreciate it if I blamed him. So I went with blaming Marissa. Okay. So here's a different shape, a different figure. Okay? And this question, instead of saying reflect over the y-axis, let's say it says reflect over the x-axis. Oh, I can't do that. Panic. Panic. How do we do that? We don't know how. Oopsies. Okay? You can figure that out. Super easy. Okay? Because this is your mirror point, and so everything is going to be the same distance away from your mirror. Okay, so let's get in that arrow. So we have 1, 2, 3 units away. So 1, 2, 3 units away. Okay, up to Z prime. Boom. Okay, there's N. So we have N prime. Okay, it's 4 units away. 1, 2, 3, 4. 1, 2, 3, 4. Okay, again, notice it's 10 to the right, and this one's still 10 to the right. So this is actually pretty easy because we could just know that this is positive 4, so this becomes negative 4. Okay, and then that last point, point A, all the ways away. Boom. Okay, so up here we have triangle NAZ, NAZ. Okay, and down here we have triangle N prime, A prime, Z prime, or we could say triangle NAZ prime. Shout out Nazanin. Okay. That's pretty much the lesson. Let me do a time check here. Okay, good. It's pretty much the lesson, but don't turn off, don't exit now, because I'm about to explain a little bit tricky part that students often get messed up on. Okay, and it's my fault because I've never really explained this well, so I'm hoping that I explain it a little bit better this time. So in the last question, we reflected over the y-axis, and in this question that we're just finishing here, we're reflecting over the x-axis. Okay, but these are not the only mirror points. You can be asked to reflect anywhere along the Cartesian plane. Okay, so you might get a question that says, reflect over y equals 2. Okay, or reflect over a line that would cross through y equals 2. Now let me explain what that means here. Okay, when y equals 2, we're saying that there is no x coordinate. So the x coordinate is 0 and y coordinate is 2. Okay, so a line that would go through y equals 2 would look like this. Super important. Super, super, super important for the independent work. Super important for a project assignment I'm giving you this week. And super important for the test. Okay, this is like the number one mistake why kids mess up on my ticket here. It's because of this one. They understand how to reflect over the x-axis and how to reflect over the y-axis, but they don't understand how to reflect over the y equals 2. Okay, or y equals 7, or y equals negative 4, or negative 13, or negative 200. Okay, so how we do this is the exact same. It's literally the exact same. What is different here is that we're not going over the x-axis. We're going over this imaginary line that we have drawn in. Okay, so let's get rid of all the last question so we don't have to see it on our screen. Okay, so we're going to count how far r is from not the x-axis, because that is not the mirror point that a question said. The mirror point has stated y equals 2. So this is our mirror point. So we're going to count. It's 1, 2, 3 units away from the mirror point. So we're going to count 1, 2, 3 units away, and we're going to plot r prime. Okay? Does that make sense? Okay. Same thing here with B. Okay, and with O. That's the far one. Put there. Connect the dots. A lot of times I have students forget to connect the dots when they're doing figures, and don't forget to connect the dots. Make your shape. Okay. Use a ruler. Cole, Dylan, Anish. Use a ruler. Okay. So here's what I would like you to do. Sure. Please hold. I need to make some fixes here. Okay, here we go. So we have triangle bro, B-R-O, point B, point R, point O. You reflected it over y equals 2 to make triangle B-R-O prime, triangle bro prime. Okay. Now I would like you to reflect triangle bro prime, not triangle bro. I would like you to try to reflect the new triangle. Okay. This one. I would like you to reflect it over x equals 4. Okay. So you need to find where x equals 4 is. And so I've dropped this dot here. And you need to make your reflection point. Now, when I do these, okay, like me sitting at my desk writing these questions, okay, I will literally pull out a highlighter and highlight my reflection point. Okay, exactly what you see on screen is what I do. I make like a dotted line with my pencil, but then I actually highlight it so I know I have that visual point that I'm like, okay, all right. So here we go. I would like you to do this. This is for you to practice. Move these points. So count them. 1, 2, 3, 4. Hey, you count them. And I'll wait. Okay. Your final image, triangle bro, change to triangle bro prime. And the image that you're working on right now is the triangle bro double prime. And it's way over here. Okay. And it is a reflection of this triangle. Okay. Let me drop in all the animations. So when you go back in your rewatch or skimming, you can kind of see the answer here. Okay. I apologize. I did not change this yet. That is not -4. That is +12. And it's still -1. Apologize. These are all wrong. Oopsie. I'll fix that. Okay. All right. Again, I'm going to flash over this. So I'm only leaving this on so that when people rewatch or people who are not watching live can pause this and can practice. Okay, I'm not actually going to address this in the live lesson. Okay, here's a similar question, but now I'm saying, see how one is the y-axis and this is the x-axis. Okay, that's the lesson. I'm going to explain what you have to do this week. Okay, make sure you do the independent work. Okay, don't lose all this independent work that you're doing because you're going to be required to hand it in to me. Okay, well, if we get back to the classroom, you hand it in to me. If we don't get back in, then you're going to be submitting it digitally. Okay. Now, the independent work is a bit of work, but it's nothing compared to the project. Yes, you have a project here to do, and you have to hand it in to me. You have to submit this to me. Okay? So, you're going across Canada. Translate Canada! Hey, this project, I made it, and it took me way too long, all right, to make this. And if you think it's going to, if you're doing it, you're like, man, this takes too long. It took me like quadruple the time it takes you to do this. It took me like 5 times to make it. It took me way too long. Like, I shudder looking at all the time I spent making it. So here's how it's going to work. You're going to go to the Google Classroom, and you're going to find the Google slide assignment of Translate Canada. You're going to get that. You're going to open it up. Okay? And the first slide you're going to see looks like this. Okay? Just like in science, all of this red is our text box for you to type in your answers. Okay? And you are going on a trip. So you are starting in Vancouver, BC at the red pin. MrStav, I don't know where Vancouver is. It's okay. You come and you just have to find the red pin. Okay, so here it is, Vancouver, BC. So you see this exact point. So you're going to mark that, and you're going to zoom out, and you're going to find its coordinates. So this is 10, 11, 12, negative 13, and this is 1, 2, 3, 4. So you're going to go to this slide, and you're going to type in negative 13, comma, negative 4. Put in your brackets. Okay? Then, from that spot, you're going to translate. See the vectors? You're going to translate 8. Okay? Is this left or right? Okay? So it's positive 8. So you're going to move 8 to the right and then 7 up. So you're going to move 8 to the right. So 1, 2, 3, 4, 5, 6, 7, 8, and then 7 up. Did I say 1, 2, 3, 4, 5, 6, 7? So that's your new point. Okay, you need to find the coordinates of that point. So negative 5 and was it positive 3? You're going to go put that in. Negative 5, 3. Okay, then you're going to follow the rest of the steps until you arrive at another destination. So let's say you end up right here, and you would just see that this is where I am, in Yuvik. Okay, so you write that down. Okay, maybe you end up right here, and you would write down that you're at Churchill. Okay, so listen very, very carefully. This is mad important that you are able to do this. Okay, if you can't do this, you won't be able to do the test. Did you hear me on that? If this is too hard for you, you will find the test too hard. Okay, so that means if you can't do this, it's fine, but you need to come and ask for help. You need to come to math help, maybe once, maybe twice. You say, MrStav, can you help me with this? Okay. Now I want to show you. Okay, the PowerPoint. On the side panel has these individual pieces. Okay, so you can use these pieces and rearrange them. So let's say this was the translation you had to do. Okay, so that brought me to point A. So mark it point A. So these ones are for translations, and these loopy ones are for reflecting. So if it says to reflect, you can reflect, show that, okay, and point your next point there. Okay. So here's what your project will look like. Okay, first slide is for you to fill in. Come on, computer, catch up. Okay, so you'll see there's the red trip, a yellow trip, a green trip, and a black trip, and then finally a blue trip that you will create for me. You'll create 3 translations and 3 reflections that will start you in Toronto and end you at PEI. Okay, I think it's kind of cool. Okay, taking the STAV Express is translating, and taking Air STAV is reflecting. Okay, so you're going to put the red root. See how the red root is here on this slide, and then you're going to, on the next slide, is the green root. And the next slide is the yellow root. Okay, so you go ahead and do that. You'll notice the second slide says delete this box to check your answers. Okay, just like the independent work, the answers are there, not for you to copy. I mean, if you want to copy them. I'm not stopping you. Okay, and I'll never know if you did or not. Actually, I will know. I will know on the test. If you can't do the test, but you hand it in the project, I will know that you copied your answers. What you should do is do the red trip, then check your red answers to make sure you did all the steps right. If you're not in the right spot, then you need to go back and say to yourself, what did I do wrong? And then that will help you understand, oh, I'm not reflecting right, okay, or I'm not translating right. Okay, maybe a common error is you're going up and down before you go left and right. Okay, that will throw off your whole trip. Last year I had students say to me, MrStav, this doesn't work. I'm in the middle of the ocean. Then you did something wrong. Okay, so that is Translate Canada. Okay, so I will be asking for that to be completed and handed in. Okay, perfect for being stuck at home. Okay, because you could travel Canada, travel your country while being isolated. I think it's kind of funny that we're doing a road trip in math when we're all isolated and not allowed to travel. That's okay. This is math. It's a completely different thing. Okay? So that's what you're doing this week. You're doing the independent work, and you're doing Translate Canada. Some of you are interested. You're playing the games at home. One of the math games was going to be Cartesian Battleship. So it was Battleship, but with a Cartesian plane. So I'll post that, and you can print that off, and you can have some fun with that. Okay? I apologize for the incredibly long lesson. I was doing some review, and then this is just kind of like a longer concept. Okay, I would normally break this down into multiple large lessons, but because this is in the YouTube format, I wanted it in one video, and so that you can go back and watch it all in one shot. Alrighty then, ladies and gentlemen, I look forward to seeing you at Guided. If you haven't been paying attention to Remind, Socrative is live right now for you to complete your exit ticket for the last 2 weeks for volume of a cylinder and surface area of a cylinder. Okay, you need to go and complete that. You get 3 attempts at it. I will average your best 2 attempts. Okay, so go ahead, make sure you do that so that I don't have to chase you and say, hey, I need you to do this for me. Okay, so make sure you go ahead and you sign up for Guided with Mr. Stav, bit.ly/Stav online guided. And with that, good luck, you guys. Have fun with it. Go slow, go back to the video, rewatch some important points, and enjoy traveling Canada. I think you'll just have a blast doing it. All right, I'm gonna go to sleep now. Me now. Yeah. Peace out, everyone. Justin says the last couple of videos ended too abruptly. So Justin, I'm trying not to end abruptly for you. So this is me saying goodbye, Justin. Goodbye. Goodbye, everyone. Goodbye.